Hello, this video we are going to go over how to translate graphs, just some of the translations for the basic functions. So we're going to start out by looking at four basic functions or four basic graphs, and I want you guys to try to commit these graphs to memory to the best of your ability. These functions are also called, the four that we're going to graph right now are called the parent functions for that family of functions. And basically it means it's like the most basic function for that type of function. So we're going to start out with a linear function. A linear function, the parent function is f of x equals x. Oops, sorry about that. All right, so let's graph f of x equals x. Remember that f of x is the same thing as y, so we're graphing y equals x. And so what that means is whatever x is, y is going to be the exact same thing. So if x is 0, y will be 0. So the point 0, 0 would be on that graph. If x is 1, y is 1. If x is 2, y is 2. 3, 3 will be on the graph, 4, 4. And same thing in the negative direction. So graphing that line, we have a diagonal line with a y-intercept of 0 and a slope of 1, because the rise over run is up 1 over 1, up 1 over 1. Okay, so that's the parent function for linear functions. Moving on, we're going to look at the quadratic function. The parent function, or the most basic quadratic function, is y equals x squared, or f of x equals x squared. When we graph a quadratic, it's always going to give us a parabola, which is like a U-shaped graph. So let's look at, I'm just going to make a table of ordered pairs here, and we'll graph those. So if I plug in -3 for x, and remember the x value is a -3, so we're squaring a -3, which means -3, times another -3, which is actually +9. Squaring -2, you get 4. -1 squared is 1, 0 squared is 0, and then that just goes back up again. Okay, so let's graph these points. -3, 9 is off the graph, but it's going to be way up there somewhere. Just kind of have an idea of where it would be. And then -2, 4, right here. -1, 1, 0, 0, and then the same thing on this side. So we end up with this U-shaped graph. And again, if you can remember those coordinates that we just graphed, they're just the value of x, whatever x is that number squared. It will help you with when we go through the translations. So I have 1, 1, 2, 4, 3, 9, it would be 4, 16. And then this is a line of symmetry, that x equals 0, and so those points are reflected over that line over here. So -1, 1, -2, 2, 4, etc. Okay, the next basic function we're going to look at is called the rational function. And the parent function for that group of functions is 1 over x. So we're going to graph this 1 over x. So f of x equals 1 over x, and I called it y here, which means the same thing. But if I put in a -3 for this x here, I'm going to get 1 over -3, which is -1/3. And think about, like, if it was -4, it'd be -1/4. So as x goes more and more negative, it becomes a smaller and smaller fraction in the negative direction. But a smaller and smaller fraction is actually going to be approaching 0. Like, so if I put -3 1/3, it's maybe about right here. And then 1/4, or if I put in -4 comma 1/4 would get even closer to 0, and so on and so on. Okay, so -2 is going to give us -1/2. -1, 1 over -1 is -1. So I have this point -1, 1. 0, what do you get when you have 1 divided by 0? Well, you cannot divide by 0, so this is undefined. And what we have is called a vertical asymptote at when x equals 0. And the graph, you can never plug x equals 0 into this function, so it's not going to have a y coordinate associated with it. Well, let's keep going here. 1, if I put 1 over 1, I get 1. 1 over 2 is 1/2, and then 1/3. And so On the other side, when x is positive 1, we're up here, 2 comma 1/2, so we're approaching 0 again because it's going to go to 1/4 and 1/5. What happens, let's see what happens like if I put in 1/2, like a number that's less than 1. I would end up with 1 divided by 1/2. And if we write that like when we were in 4th grade, when you first learned division, if we write it like this, 1 divided by 1/2, remember when you divide fractions, you need to flip the second one and multiply. So 1 over 1 times 2 over 1 becomes 1 times 2 is 2 over 1, so it becomes 2. So 1/2, when x is 1/2, would be up here at 2. And if x is 1/3, do the same process, you would get 3. And so the function keeps going up higher and higher and higher, but remember we can never put in 0. And so the graph looks about like something like this. And this graph is not continuous because I need to pick up my pencil to start drawing this part in. And then again, if we put in a negative 1/2, it's going to be this same process, but with a negative, so it ends up being -2. So when x is negative 1/2, I'm down here at -2. When x is a third, negative 1/3, we're going to have -3. And so it's going to head off this way towards negative infinity, actually. On the positive side, it's going up to positive infinity. On this side, it's going to negative infinity. And then these guys, as x gets bigger and bigger and bigger in both the positive and negative direction, it's approaching 0. Okay, and then this other function here that we're going to be looking at is the absolute value of x. Remember that absolute value makes it positive. So if you put in like a number like 0, the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So we get this same kind of graph that we got with the linear function, except for when we go in the negative direction. If I put in -1, what's the absolute value of -1? Well, it's 1. So -1 is going to go up at, going to be at +1. -2, 2, -3, 3, etc. It goes off like that. So instead of with the linear function, it came down like this, but because we're doing absolute value, all those become positive, and so it flips up and makes this V shape. So again, remember these basic functions, and then we'll look at something called transformations of those functions. Okay, so we're going to start with the linear function. Remember the linear function is a line with a y-intercept of 0, a slope of 1. And what happens when instead of just graphing y equals x, we graph y equals 2x? Well, if we have y equals 2x, that changes the slope of the graph. And it's still going to go through 0, 0, because if I put 0 in for x, 2 times 0 is 0. If I put 1 in for x, it's instead of being 1 though, we're going to multiply that 1 by a 2. So we have the point 1, 2 instead of 1, 1 on this graph. So what it's really doing, that 2, is stretching all the y-coordinates. It's making every y-coordinate be twice as big as the linear function. So instead of 3, 3, it's going to end up, 2, 2, it's going to be 2, 4, because it's going to be twice as big. So it's going to change the slope of that graph. And instead of 3, 3, it's going to be 3, 6, etc. And the same thing happens in the other direction. So that 2 changes the slope of the graph. And likewise, if I put in a 1/2, it's going to be still going to go through 0, 0, because half of 0 is 0. But when I move over 1, instead of going up 1, I'm only going up a half. And when I go over 2, instead of going up to 2, I'm going up just to 1. So that I have this point 1, 1/2, and 2, 1. 3, 3, it'd be 3, 1/2, etc. So it's going to change the slope. And in transformation language, it's a vertical stretch of factor 2 for that first graph, and a vertical compression of factor 1/2. All of the y-coordinates are getting cut in half compared to what they were prior to that. Okay, so multiplying, that was when we multiplied by a number, like 2 or 1/2. That changed the shape of the graph, like it stretched it vertically. This third part of 8.5 is on vertical translations. So that other one is called a vertical compression or vertical stretch. A vertical translation is simply going to move the whole graph up or the whole graph down. So let's look at these three graphs right here. I'm going to graph y equals 1/3 x plus 0. Has a y-intercept of 0 and a slope of 1. So I'm going to rise over run. I'm going to go up 1 and over 1, 2, 3 to get to my next point. Up 1 over 3 and down 1. If I go down, then I have to go to the left 3 units. And I end up with a graph, sorry, not a very straight line, but a graph that looks something like that. If I graph and compare that to the next one here, 1/3 x plus 2, that has a y-intercept of 2 instead of 0, but has the same slope. So these lines are going to end up being parallel. So when I go up 1, I go over 3. If I keep, I can go down 1 and back 3. Graphing that line, adding this 2 right here, translates the whole graph, the first original 1/3 x plus 0. When I add 2 instead of 0, it translates the whole graph up 2 units. And then likewise, if I subtract 3, remember that's the y-intercept, -3, but the slope is still 1/3, so up 1 and over 3, down 1, back 3. It's going to have the same slope, but it's going to be translated down 3 units. So when you add or subtract a number to a function, it's going to translate it up that many units or down that many units. And once you learn these transformations, it makes graphing a whole lot easier. Okay, so in general, this is for your notes. In general, if you have a linear function, and this actually works for all functions, but if you have a linear function, y equals mx, if that's our initial graph, if I add a number k, it's going to make the whole graph go up k units. If I subtract a number k, it's going to make the graph go down k units. So let's look at the graph of y equals x squared, or f of x equals x squared. And remember that we just graphed this. Why don't you stop the video and try to graph that by memory. All right, so it should look like this. It's going to be 0, 0 for the vertex, 1, 1, 2, 4, and then we're already off the graph. And then -1, 1, -2, 4. Now, how does that compare to this other function, g of x, which is x squared minus 5? So what it's going to do is it's going to shift the whole graph down 5 units. So if I wanted to, if you don't have, you probably can't do this because you don't have a smartboard, but it's going to be this exact same shaped graph, but every point is going to move down 5 units. So the vertex, instead of being at 0, 0, will be down here at -5, 0, -5. Okay, so we will talk about horizontal translations in the next video.